Hello everyone, welcome to my channel. We are going to answer this question. In an isolated system, if the moment of inertia of a rotating object is halved, what happens to the object's angular velocity? So in this question, the system is isolated and the moment of inertia becomes half. We are looking for angular velocity after the moment of inertia becomes half. So since there is no any external torque because the system is isolated, then torque is zero and angular momentum becomes constant. L is constant. But L is given by I times omega. So before moment of inertia becomes half, we had Li as I omega I. And after changing the moment of inertia, angular momentum becomes IF omega F. So since L is constant because of no torque on the system, then I omega I is equal to IF omega F. And IF is I over 2 because the moment of inertia has been halved. And if we substitute this equation, then we get I omega I over 2 omega F. If we cancel out I in this equation, then omega I becomes 1 over 2 omega F. And omega F becomes 2 omega I. That means angular velocity becomes double after moment of inertia becomes half. Thanks for watching. Please follow the other videos in my channel.